Okay, in this video, we're going to talk about max and min problems from college algebra. So right now, the only kind of problems you really know how to find max or min of is a quadratic function. So let's think about quadratic functions just for a second. If your quadratic function, so I'll just call it, oh, that's rainbow pen. Let me get a black pen. Okay, so let's call your function f of x. It could be written in standard form, a times x minus h squared plus k. And if a is positive, your graph is opening up, and hk is a minimum value because hk is a vertex, so it would be the lowest value. If a is negative, then your picture will be opening down, so HK will be the highest point or the maximum. This is best case scenario. You've got a function that's in standard form. But now, if your function is not in standard form, so somebody like went and squared it, so they FOILed it, they distributed the a, and then they added the k, then you've got a quadratic function that looks like this, ax squared plus bx plus c. And the same rules still apply. If a is bigger than 0, your graph is going to open up, and your HK is going to be a min. And if A is less than 0, your graph is going to open down, and HK will be a max. But the problem here is that I don't actually have an H and a K, right? I've got A, B, and C. So the way we find H and K is H is negative B over 2A. And K is whatever you get when you plug that in. So I think there's like some formula out there for how to find K, like using completing the square, but I don't know. I think it's just easier to just plug it in. Okay? So these are the rules for quadratic functions. And most of the time, if your quadratic function is just in function form and somebody says find the vertex, you're like, hey, I could totally do that. I'll just find HK. But when it comes to a word problem, a lot of people panic. So let's look at this word problem. This word problem says, and notice I'm not going to write anything. I'm just going to read it. That's the first step. Just read it. Okay, so a ball is thrown vertically upward after t seconds. Its height h in feet is given by the function h of t, which is 108t minus 16t squared. What is the maximum height that the ball will reach? Do not round your answer. Okay, so let's think about this. H of t is the function that's mimicking the height of the ball. So now, you can even like just picture you throw a ball up and then it comes down. So this is a parabolic trajectory, all right? Fancy words for a parabola. So now, this makes sense because here my h of t is negative 16 t squared plus 108t. Now notice I wrote that with my squared first and my single second because that is the order on ax squared plus bx plus c. It goes squared, single, constant. No constant here. It's because it was thrown, I guess, from a ground. So now we can tell that our a is negative 16, which is less than 0, which tells me that my parabola will open down, which is exactly the picture I had pictured for throwing a ball. So now the HK will be a maximum point, right? Whatever this HK is up here. So our A value is negative 16 and our B value is 108. So we need to do for H minus B over 2A. So that's minus 108 over 2 times negative 16. So let's just plug that into a calculator. 108 over 32. So 108 over 32. Oops. 108 over 32 equals 3.375. Not a great answer because they didn't want you to round. So let's do it the kind of quote unquote long way for this fraction. So I've got negative 108 over negative 32. And both of these are definitely divisible by 4. I don't know if they're both divisible by something else, but they're definitely divisible by 4. And the negatives cancel. So 4 goes into 100 25 times, and then 2 more, so 27 over, and then 32 divided by 4 is 8. Now 27 is 3 times 3 times 3, 8 is 2 times 2 times 2, so I can't actually simplify that fraction. So the h is 27 over 8, and k is whatever you get when you plug that in. So h of 27 over 8. So I need to do negative 16 times 27 over 8 squared plus 108 times 27 over 8. Now let's see. So this is going to make negative 16 times 27 squared. Let's see what that is. So 27 times 27, 729. Whoops. 729 over 64, right? 8 squared. Plus, and I'm just going to keep this as 108 times 27 over 8. And I'll simplify these fractions in the middle. If you've got a calculator that does fractions, just do it. Oops. So 64 is divisible by 8, right? So divided by 8 makes 8. 16 divided by 8 makes 2. Oh, 8 is divisible by 2, and it makes 4. So I guess 16 went into 64. So on top, I've got negative 729. And on bottom, I've got 4. So now plus, now here, I want to make sure my bottom turns into a 4. So I'm going to divide this guy by 2 to make 4. And I'll divide this guy by 2, and that's 54. So I need to do 54 times 27. 54 times 27 equals 1458. So I've got plus 1458 over 4. And the reason I kept them both over 4 is now I can just add them. So 1458 minus 729 equals 729. Hey, that's pretty cool. So this equals 729 over 4. And just so you can get an idea of what that number is, that's 182.25. Okay, so now let's talk about what these mean. Like, so this location is 27 over 8, comma, 182.25. So now, in my function, the input variable is t. So the first part of my coordinate is a t value. So this guy is t equals 27 over 8, which is 27 over 8 is the 3.375. Again, I want you to get like an idea of what this means. So 3.375. Time was in seconds. So at 3.375 seconds, the height of the ball is going to be 182.25, and the height was in feet. So feet. So the ball goes up for 3.375 seconds, gets up to 182.25 feet, and then starts falling down, 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 down. So now let's answer the question. The question was, what is the maximum height? So which one of those values was the height? The 182.25 feet. And remember, that was this fraction 729 over 4. So now let's take it one step farther and give you a problem where I haven't actually given you the function that mimics what we're trying to figure out. Instead, you have to figure out the function. So let's read the problem. We're not writing anything down. We're not assuming anything. We're going to read the problem all the way through and then figure out what it's asking. So Alonzo has 440 meters of fencing. He will use it to form 3 sides of a rectangular garden. The 4th side will be along a house and does not need a fence. As shown below, one of the sides is length x. So I didn't actually copy the actual question, but the question is, what dimensions maximize the area and what is the maximum area? So here, I'm not actually giving you the function. You have to figure out that function yourself. So let's think about this picture. This guy's got 440 total meters of fencing. If he puts x on this side, it's a rectangle, so he has to put x on this side. And now, since it's a perimeter, the other side plus the x has to equal 440. So let's just say like y plus x equals 440. So this side is y plus 2x, and that has to equal 440. So y has to equal 440 minus 2x. So this guy here is 440 minus 2x. Now we want to maximize the area. So the area of a rectangle is length times width, or base times height, however you remember it. And basically in my picture, it's just green times blue. So the length we'll call x, and the width we'll call 440 minus 2x. And this is the function that tells you the area. So area equals 440x minus 2x squared. And just like before, I'm going to put this in the right order. So minus 2x squared plus 440x. So now, since we want to maximize our area, we want to find the vertex of this quadratic function. Now again, this is negative, So if I graph this quadratic function, it'll have a top point, and that top point will be hk, where the h is found by doing minus b over 2a, and the k is found by doing a of whatever we get when we do, so I'm just going to put a of h, whatever we get when we put minus b over 2a. So my b is 440, so negative 440 divided by 2 times negative 2. So that's negative 440 divided by negative 4, which makes positive 110. Then I have to plug in 110. So I've got 4, well, let's do it the right way. Negative 2 times 110 squared plus 440 times 110. So now I'm going to put those in my calculator, and the numbers will be relatively big. So 110 squared times negative 2 is negative 24,200. And then 440 times 110. So 440 times 110 is 48,400. And then I have to subtract those. So minus 24,200. So 24,200. Okay, now let's think about what these h and k mean. And we use h and k in general, but we have to refer back to the function to decide what the input variable is and then the output variable. So your h is your input variable, k is your output variable. So here in my function called a, the input was x. So 110 is the x that's going to maximize the area. So if x is 110, what is y? Well, y would be 440 minus 2 times 110, which makes 220. So what are the dimensions that maximize the area? 110 feet by 220 feet. And what is the area? Well, the output to our function was the area. So this guy here is the area, which is 24,200. So the max area is 24,200 square feet.